Okay, we're going to pick up where we left off. Let me just get a little thing to work with here. I've got my little red invisible ink that I can check mark things. So in this section, patterns and linear functions, what you're going to be doing is working with linear line graphs, and they're called linear functions. And you're going to see a pattern that develops when you start to look at how am I going to formulate this equation, right? You'll see the pattern, and from the pattern, you can say, oh, well, then if it's x, then I can just plug the x in where I put the 1 or the 2 or the 3 or the 4. So here we go. In a relationship between variables, then you have that the dependent variable y is usually y, changes in response to the independent variable. And I put the x there only because many, many times it's going to be x and the dependent will be y. Then values for the independent variable are called domain, and they're also called input. And the values for the dependent variable y are sometimes called range and output. So if we consider in this next example, we have an equation, y is equal to x plus 3, and you were supposed to, in vocabulary terms, 1 through 4 above, you associate one of those two words, one or two sets of those words above that mean kind of the same thing, but something a little different about it. So for x, you have the independent variable, the domain, and the input. And for y, you should know those three words are going to be the dependent variable, the range, and the output. Sometimes I like to say outcome instead of output, because outcome kind of implies like an n value. And when you input x, you output a y. You know how we put y by itself on one side of the equation. So then in the next problem, we were looking at the amount of toothpaste in a tube decreases each time you brush your teeth. So identify the independent and the dependent variables of this situation. So the independent is going to be the time it takes you to brush your teeth, or the time you brush your teeth. And then the dependent variable is the amount of toothpaste left. Certainly, it's kind of like a reaction to you brushing your teeth. What's happening is that you brush your teeth, it goes down, you brush your teeth, it goes down. The toothpaste goes down, 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 until your toothpaste tube is empty. The amount of toothpaste remaining in the tube then depends on the time you spend brushing your teeth. When you make that statement, it tells you, oh, the dependent variable is the amount of toothpaste in the tube, right? So that's that one, example 1. Example 2, what we did is we looked at the number of rectangles, and I said I'm going to make that n, and the perimeter of the figure that they form. So the perimeter, I didn't say this in class, but I'm going to say the perimeter depends on the number of rectangles, really, because it seems like it increases, right, as you go over. So what I did is I set up some numbers to take a look at, where I had 6 times 2 in each situation was constant, right? All those are constant. So 6 times 2 is going to be 12 for each of them. And then you have 1 times 2, 1 times 4, 1 times 6, 1 times 8, right? So then it looks like twice the number of rectangles plus 12, if you look at this, because it's going to be 6 times 2, and then in each situation you have 1 rectangle, and that's a 1, look at this, times 2. And you have 2 rectangles, and you're looking at how do I get to 4? 3 rectangles, and you get to 6. 4 rectangles, and you get to 8, and you can kind of clearly see that that's just a doubling. So that if you look at your last one, you're going to say, okay, well, then it's going to be 1 times 2 times the number of rectangles, right? So then when we build our table, we built it with 1, 2, 3, and 4, right, for all of these. And then what we have then is you can see where I highlighted down here to show you that, oh, we have 1, 2, 3, 4, and it pops up into our equation as 2 times 1, 2 times 2, 2 times 3, 2 times 4. So we have that, we want to build in our variable, which is n in this case, n rectangles. And we get 14, 16, 18, and 20 for 1 through 4. And then for the nth number of rectangles, we're just going to build 12 plus 1 times 2n. And then that's what we get for our equation. You can see that that looks like a linear function. This is a linear function. Okay, and so you see our graph, we have the number of rectangles n, and we have the perimeter p. And we see that when we input 1, we get 14. So we just have the graph illustration. 2, we get 16. 3, and that would be the point 216 on the graph. Then we have the next point would be 318, and then the last point is then going to be 420. Okay, and then after that, we have one more thing to discuss, and that has to do with functions. A function is a relationship that pairs each domain with exactly one element of the range, or domain X with exactly one range Y. A linear function, then, is a function whose graph is a non-vertical line, or part of a non-vertical line. So non-vertical in this case is going to mean not straight up and down. So then when we're talking about the next example, you can make a bubble solution by mixing 1 cup of liquid soap with 4 cups of water. So represent the relationship between the cups of liquid soap and the cups of bubble solution. So I started to do a pattern here of what's going on, but I think you could really say that the bubble solution is 5 times the cups of the, we're just going to say liquid soap. So if you look at some of the values that I have here, that when you have a 1, it's going to give you a 1, I didn't put it here, 1 times 1 plus 4. If you have 2, it's going to give you a 2 times 1 plus 4. If you have a 3, it's going to give you a 3 times 1 plus 4. And if it gives 4, you get a 4 times 1 plus 4, otherwise known because it's the 1 cup of liquid soap with 4 cups of water, right? So you end up with 5 cups total. That should make sense. So we end up with this equation, y is equal to 5x plus 0, or just y is equal to 5x. Okay, and we plot the points on the graph as you see. And then let me put an x here, that's it, and we just get 5 times x. So we plot the points on the graph, 1, 5, 2, 10, there's 2, 10, a 1, 5 here, 2, 10. So I could put the order pairs by all of them. Here's 3, 15, and then 420 would be the last one, okay? All right, so that gives you y is equal to 5x. And I'm going to erase the 0. You could put it there if you want to, but you don't need it. And is it a function? Yes, it is. X gets only 1 y. And then we have the last couple problems here. For each table, determine whether the relationship is a function. So now when we work with this, we want to see the rate of change of y with respect to x. And you can kind of see that that's going to be, well, it goes up twice as fast for the y's than the x's. But when you see these numbers, you can kind of see that you have 1 times 2. If you go straight across here, 1 times 2 is 2 plus 1. And 2 times 2 plus 1 is 5. And 3 times 2 plus 1 is 7. So that change in y that you're seeing there is going to be part of a multiplying factor. And that's going to be 2 over 1. But you can kind of use that to say, wait a second, I'm just going to double my input here. And then how much do I have to add? So when you look at what I said there about starting, here's your starting value, remember, that I'm starting at 0. So if I put 0 in, I have to be left with 1. And remember, so if I start at 1, that's going to be the plus 1 that you put on your equation. The same thing is going to happen over here, or as well over here, where I have delta y is plus 1 for all of them. And then delta x, or the change in x, is going to be plus 1 for all those. So you could say y is equal to x, but then that's not going to help you because it's not going to be y is equal to 1x. You need to add something to start off. So you know how 1 times 1 is 1, plus 6 is 7. 1 times 2 plus 6 is 8. 1 times 3 plus 6 is 9. So you have the same relationship. You're just looking at this first part. If you plug 0 in, it helps you. You get that point. That point is called the y-intercept from last year. But you get that constant that is not part of the variable expression. The delta y and the delta x are going to help you to write the 1, because that'll be 1 over 1, which is just 1 in there, okay? So you're going to take the delta y, the change in y, over the change in x each time, okay? All right, and then we graph those. When you graph them, you already have your table of values, so you can see both of them are linear. You can connect those points with a line, and you see that in both cases, you have this point where you start off, here's 0, 1. Here's 0, 6. Okay? This is the equation here. This is the equation over here. Okay? And both are linear functions. You have homework for 4.2 homework, and that is in Schoology in today's agenda for you. Okay? Have a great night. See you when I see you.